open Q&A. So the first one is just trig functions. And one of the things that I wanted to add about this was when you're doing the trig functions, okay, one of the things when I first taught this, I don't know why I'm having trouble speaking, but when I first taught this, I looked at this and a lot of students, really didn't understand. They had been exposed to the 6 trigonometric functions, in geometry class, but they didn't really understand them. And actually, when I first, happens a couple years ago, I remember I first went through the trig functions and I didn't really understand them. Like I knew what they were, I knew how to apply them, but I didn't really know what they were all about. So, let's just say we have a triangle, right? It's a right triangle. We know that's 90 degrees. And then we have some angle, and we're going to use the Greek symbol here, theta, today. It could be X, it could be Y. Now, obviously, we are very familiar with, looking at a triangle. Same triangle here, but just looking at the sides of the triangle, where A and B were the legs of the triangle and C was the hypotenuse. And we created that relationship, right, which was the Pythagorean theorem. Now, so that was a nice little relationship that came out of right triangles. But another relationship, or another way that we looked at comparing things, was like, how do these side lengths compare of this triangle? For instance, like we have A, B, and C, right? Now we know from the Pythagorean relationship that a squared plus b squared is equal to c squared, right? And that c is always going to be larger than a and b. But if we want to look at this relationship based on an angle, one thing we could say is like, based on this angle, how big is B compared to C? Or we could say, how big is the opposite side of this triangle from theta compared to the hypotenuse? And that is what we call the sine, right? So really, all the trigonometric functions is a comparison. They're really just comparing how big is this one side to the hypotenuse. And the same thing can said, for cosine. Cosine of theta is just a comparison here of this side, which we call the adjacent side, to the hypotenuse. And then last but not least here, we can have tangent of theta, which is a comparison of the opposite over the adjacent, which would be B over A in this case. Now, again, the last thing I just want to cover is, these are comparisons. These comparisons, though, are based on where the angle is, like what the function is. Like this reads sine of theta, cosine of theta, tangent of theta. So they are dependent on which angle you're talking about, because if I was going to talk about alpha in this case, and I say, what is the sine of alpha? It's not going to be B over C, because the opposite side, which we refer to in sine, is going to be directly across from the triangle. So sine of alpha is going to be A over C. All right, and cosine of alpha is going to be B over C. And then the tangent of alpha is going to be A over B. Okay, so therefore you can kind of see like that relationship. But again, it's a comparison. That's all we have for trigonometric relationships, is they're just a comparison of sides of a triangle. How big is one side compared to another side? And then obviously we could also go through the reciprocal functions, and that's basically those relationships flipped, okay? But hopefully that at least gives you an idea of what the trig functions are. And so you can kind of like